Hello everyone, in this video we're going to talk about some rational exponents. So before we get into that, what does the word rational mean? Well, if we think about our real number system, we have irrational and rational numbers. And rational means it can be written as a fraction. Okay, so when we say rational exponents, we're talking about fractional exponents or exponents that have fractions. Okay, so before we get into this, let's talk about a property of exponents that hopefully you've learned before. I will link the properties of exponents video I did for Algebra 1 in the description below. So you can check that out to talk about, I think there's about 8 properties of exponents that we need to know, or laws of exponents. And so check that video out if you want to have a quick refresher on those. So the one we're going to focus on in this video is called power of a power property. And so what I referred to that one in the video is PPP, telling me that when I see two powers next to each other, I'm going to take the product of those powers. So power product. So let's use that to help illustrate our rational exponents here. So let's say we have a to the 1/2 power, and we're going to raise that to the second power, so we're going to square it. So we could rewrite this as a to the 1/2 times 2, right? Because we have two powers, so how would we evaluate that? We would multiply those two powers. Well, what is half of 2? It is 1, right? And so a to the first power is just a. Okay, so let's go down to the next one. So if we did a to the 1/3 times 3, we get the same thing. A to the first is a. A to the 1/4, there should be a 4 here. And then times 4, we get a to the first, which once again is a. So now let's look at what has happened here in blue. It says because a to the 1/2 power is a number whose square is a, you can write the square root of a as a to the 1/2. Similarly, cube root of a is equal to a to the 1/3, and the fourth root of a is equal to a to the 1/4 power. So it gives us this general rule down here. So the nth root of a is equal to a to the 1 over n for any integer greater than 1. So basically, the square root of 9 is the same as 9 to the 1/2 power, right? The cube root of 125 is the same as 125 to the 1/3 power, right? So we can kind of go back and forth between a radical form and a rational exponent form. So now let's talk about what happens if we have fractions that are not 1 over another number. How do we evaluate that? Well, it says let a to the 1 over n be an nth root of a, and let m be a positive integer. So we have a to the m over n, and so basically we don't have 1 over a number. We have maybe 2 over 3, or 5 over 3, or 6 over 5, something like that. So we're going to basically break this apart. So we're going to go from a to the m over n, and we're going to basically undo the power product, or power of a power property here. So we're going to have a to the 1 over n, raise that to the m power, and now we can use that rational exponent rule we just looked at, where we said, hey, a to the 1 over n, we know that's the nth root of a, so we could evaluate the square root or whatever root we're working with, and then we can raise it to that power of m. Now the only difference here is if we have a negative fractional exponent here where the numerator is not 1. So basically we're going to do 1 over a to the m divided by n power. Then we'll do the same thing. So basically we're doing the same thing we're doing at this example, but we're doing it in the denominator. And essentially that's how we evaluate a negative exponent, right? We move to the denominator, numerator becomes a 1, and we go from there, okay? So we're going to do 4 examples here where we evaluate some rational exponents. All right, so number 1, we have 64 to the 4/3 power. So I'm going to go ahead and rewrite this as 64 to the 1/3 power, and I'm going to raise that to the power of 4. Okay, so essentially what we did was, I see 4/3, I think, okay, that could be 1/3 times 4. So now I know 64 to the 1/3 would be the cube root of 64, and then we're going to raise that to the 4th power. So the cube root of 64 we know is 4. And then 4 to the 4th power would be 256. All right, number 2, we go down here to the bottom. We have 16 to the negative 5/4 power. So I'm going to go ahead and write this as 1 over 16 to the positive 5/4. And now we're going to go ahead and begin to break that apart. So 1 over 16 to the 1/4 raised to the 5th power. Now that's going to become in radical form the 4th root of 16 raised to the 5th power. And so now the 4th root of 16, we could type that in our calculator, but you might know that as just 2. And then 2 to the 5th power would be 32. So we end up with 1/32, 1 over 32 as our answer for number 2. All right, number 3, kind of the same thing. We got a negative fraction here as our exponent, so 1 over 32 to the 3/5. Now we can begin to break that apart. So 1 over 32 to the 1/5 raised to the 3rd power. So that's going to be 1 over the 5th root of 32 raised to the 3rd power. And the 5th root of 32, well, we just did 2 to the 5th and we got 32, so we know the 5th root of 32 would also be 2. So 1 over 2 cubed, and 2 cubed is 8, so our fractional answer would be 1/8. And our last one, we have 16 to the 3/2, so we could write this as 16 to the 1/2 raised to the 3rd power. And 16 to the 1/2 would be the square root of 16 cubed. Square root of 16 would be 4, and 4 cubed would be 64. Okay? And so that's a little bit about rational exponents and how we can evaluate to figure out what the rational exponents actually mean.